AP Cram, Calculus AB, Free Response Exam Review. Question 25. The integral of a number raised to the x power or to the power of a variable. All right. Grass clippings are placed in a bin where they decompose. For t is greater than or equivalent to 0 days or less than or equivalent to 30 days. So this is like a month. The amount of grass clippings remaining in the bin is modeled by A of t is equivalent to 6.687 times 0.931 raised to the t power, where A of t is measured in pounds and t is measured in days. Find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass. So solving this problem isn't that complicated, but it does require tribal knowledge. When I say tribal knowledge, I mean if your instructor, your professor, or someone like myself doesn't chat this up with you, it won't be like obvious to most people, even if you're really good at reading your textbook or, grasping theoretical knowledge. But there are many of you who understand this. But for people like myself who don't readily comprehend how to figure this out based on the information given, sit tight, the answer is coming soon. And for those of you who do know what's going on, write out your answer, solve it, and then press pause, and then press play when you figured it out, okay? Oh yeah, and the bin, the definite integral. Well, I think I just gave away the answer. You're going to have to consider the time frame between 0 and 30 days, okay? All right, so in order to figure this out, there's like a two-step process. The first step is to come up with a solution for the average amount of clippings for a time frame of 0 to 30 days, okay? So that just requires solving an integral. So you just basically take the integral of A of t, which gives you the amount of grass from 0 to 30 days, but then to find out the average, you divide it by the amount of days or the time duration. So we're dividing by 1 by 30 or multiplying by 1 over 30, okay? Now, solving an integral where you have a number, a base, being raised to the variable with respect to which you're integrating is not so obvious to some people. And if it's not, that's fine, because on this test, you can just plug this into your calculator and solve it. But for those of you who want to know the detailed process, it's like this, okay? So basically, we factor out constants, and once we're finished factoring out our constant 6.687, we're going to solve the integral for the inner expression, okay? And basically, you have to use the fundamental theorem of calculus here and just take the antiderivative. So the antiderivative of anything raised to the variable that you're integrating with respect to is just going to be the same answer. So it would be 0.931 raised to the t power divided by the log base 10 of the base. So it's going to be divided by the log base 10 of 0.931, okay? And now that we figured that out, we have to evaluate it between 30 and 0. So you plug 30 in here, then subtract this whole monster, subtract the solution at 0 from, the solution at 30 to get your answer, okay? And when you do that, you're going to get 2.75 pounds. I know I make this look really simple, but be sure to, plug in the correct numbers so that you don't miscalculate. So the average amount over this 30-day time period is going to be 2.75 pounds. But that's not the answer yet, because we want to know at what time does this amount, pop up. So at what day does the average amount pop up, okay? And in order to do that, you just plug 2.75 pounds back into the original model equation, AFT, to figure out that time, okay? All right, so basically, this is what your equation should look like. And then when you go ahead, divide both sides by 6.678, and, you take the log of both sides, you're going to get 12.415 days, okay? So this is like somewhere, I don't know, a third into, like, past the 12, a little past the 12th day, okay? But not quite the 13th day. I'm not sure how you get a fraction. Actually, a fraction of a day would be an hour. So 12 days, and I don't know, about 10 hours later. So into the 12th day, the 10th hour, approximately. Okay? All right, that's it.